Welcome everyone one more time to our last session, our last talk, presented by Daniel Hervás. And his talk will be Inside the Black Box, the Anatomy of Virtual Environment. So, Daniel, the stage is yours.
All right, thank you. All right, can you hear me all right? Everything good? Perfect. All right, so yeah, thanks for coming. Now we're going to talk about virtual environments. I will leave this always relevant XKCD as a backdrop for just some comments about the talk in general. And well, we all use virtual environments every day. It's part of our day-to-day operation with Python. I think it's a ubiquitous tool that we all rely on every day. But I feel like it's not often that we get to, let's say, see the guts of what's inside of it and how it operates so that, well, your environments are actually isolated. How does that sort of isolation function, how is it separated from your operating system packages? Why is it being done this way? And all these other kinds of things, which are what we're going to see today. I think it's quite interesting. I think it's a really cool exploration on how things function. Just one disclaimer, I will not be speaking about virtual environments in Windows. So this will be virtual environments in Unix systems. The reason is that virtual environments in Windows are kind of that that Mr. Incredible meme where he's like very happy at first and then it gets uncanny. Well, the creepy Mr. Incredible are virtual environments in Windows. It's they essentially do the same thing, or let's say they achieve the same thing. The way they have to get there is slightly different and a bit more convoluted. Part of the reason is that well, it doesn't use symlinks. You can actually symlink in Windows starting from Windows 10, but there are some caveats related to it. I do think you need admin privileges in order to do that. And for historical reasons, compatibility stuff, and just how the general pathing works in Windows, the way it's being done is a bit different. So they copy over the binaries into the virtual environment, and they do some things differently, which I will, yeah, I don't have time to go into. It's pretty creepy, and if you want to not sleep tonight, you can look into it. But we'll keep it happy and cheerful for today. So first off, a quick reminder of kind of what virtual environments are and what they do. If you try to install a package in your operating system, you will see that nowadays you're kind of not allowed to. This is what happens in my machine, and I'm sure for all of yours too. And there are good reasons for this. So you are heavily encouraged to not install packages, system operating packages using pip. And also, please do not force it with root. You generally don't have let's say you normally don't have a good reason to do it. So you get this very fun warning here, this very ominous warning about how you're going to break anything. For good reason, you might. So how does the installation work in your operating system normally? Well, these are not the only parts of a Python install, but they are the most important ones, and essentially like 90% of it. So on one hand, you have your binaries in under the bin. This is where the actual Python binaries are, where everything is. And then you have your side packages. You will get used to seeing this folder. This is where all the dependencies will live. This is all handled by the operating system. So the reason why you're not allowed to kind of install dependencies using pip is, well, there are several, but two package managers doing the same thing eventually conflict. You would lose the operating system's version control if you were to overwrite it. And essentially, the packages that your OS installs are well needed by the OS. So if you really want to brute force it, and install a version that's different from the one that your operating system requires, you might find that things break because all of these operating system packages have dependencies on specific versions of the packages that are well installed. So if you override it and you install a new one, you might just incur a breaking change. So this is the first look at how or what parts are there in a basic Python install. Now, let's look into what's inside virtual environments themselves, and we'll see how it correlates to what we've seen before. This is the output of a normal virtual environment, and what you will see inside is essentially 3 folders and a file. You have your bin, which is where your binaries will reside. You have include, which has some C headers in case they are needed. You have the side packages. These are the same that we have seen, well, not the same because then it would break, but this fulfills the same function as you've seen before in the OS image. And you have pyvent.config. We'll see how that gets read by the interpreter later and what role does it play into all of this. So now we're going to go into each one of these different folders, and we're going to, see what role each one of those fulfills and what role they play into all of this. Let's start with the side packages. It does contain, as I mentioned before, all of the different dependencies. When you start up a new virtual environment, you'll find that it's not empty. Might be slightly surprising, but it's true. Python kind of bundles pip in a way. So it uses ensure pip to copy or to generate this pip version that gets put into your side packages. This is an offline operation actually, so it's not like connecting to the internet and pulling pip from any server. This comes bundled into your Python install. They all bundle this, and it gets put into the side packages so that pip can be run from inside the virtual environment. How this pip gets run and not the operating system one, we'll see in a minute. That's how kind of the magic of virtual environments happen. For the most part, the rest of the dependencies that you see are just regular random dependencies, just to illustrate that this is where they reside. Moving on to bin, this is potentially the most interesting folder of the bunch because we have a lot of things here. First off, we have Python, but you will notice that you don't actually have the binary itself. So you see those arrows there. That means, well, the 2 first ones are pointing to the third, and the third is pointing to my operating system Python binary. This means that you don't actually have a Python binary by itself in your virtual environment. It's a symlink. So it's linked to the system's Python. So when you're running Python inside of a virtual environment, you're actually running the Python that's installed in your operating system. It's not a different one, with some exceptions. You will see that there's an asterisk there. The reason why is because this is the operation of the virtual environment module in CPython, but this is not necessarily what you will find if you use other utilities to generate your virtual environments. For example, UV, the package management dependency that I guess you all know by now, it's gotten a lot of traction, and some other similar package management tools too. They do create their own virtual environments. If you want, they do have their own utilities to create them. UV, for example, will actually pull precompiled binaries into your machine. So UV, for example, will not link to your OS installation. It will pull their own version of Python. They do this partly because of, well, they have them. Let's say that the major reason is that they can be more modular with the way that they do things, in the sense of that you can have different Python versions. You can have different virtual environments for different Python versions. So they cannot rely on your operating system having Python 3.11, for example. So they just pull it. And then if you want to create a virtual environment with Python 3.11, it just pulls it directly from source. Well, from their source. It's a precompiled binary from them, not necessarily from the Python core team. It's still safe to use and everything, but just so you know. Then we have pip. But the pip that you see here, it's kind of not the same pip that you see inside packages. So what's inside of this, it's a very simple script. And if you look into it, it's just like 3 or 4 lines. And it's just the entry point for the pip that you will see inside packages. So what this pip does is run the pip that's being previously installed by the virtual environment creation. It just goes there. The same can be said for some custom package scripts. So for example, you see that there's HTTPX in there. Some packages, some utilities have CLI tools. So they provide command line utilities for you to interact with whatever they are installing. HTTPX is one case. You can use the command line utility to do requests and stuff like that. These kinds of tools will also be put into inside of the binaries so that you have access to those when you're inside of your virtual environment. And again, we will see how exactly that ends up operating in just a second. And lastly, you have the activation scripts for the different shells. We will see what the activation script does, but you have a bunch of different default ones for a bash, C shell, PowerShell, etc. Which this is what gets run when you do a virtual environment bin activate. You are executing this, and then something happens, which we will see, which allows you to access all of the binaries under this folder. So this has been. Then we have include and pipem.config. Include, as I mentioned before, contains Hervás C extensions. It's not the most interesting of the bunch. And we nowadays have a lot of precompiled packages, so that this is not strictly necessary. So it's not deprecated or anything. You will still find some things in there occasionally, but hopefully the package you're installing has a wheel with precompiled C code if needed, and you won't have to worry about this. Lastly, we have pipem.config. This file contains what you see here. This is the actual entire output of pipem.config in my machine. And what you see here is that it has some, I guess, data pointing to how I created the environment, where the system executable can be found for my system, the Python version, and includes system side packages. This funny line of configuration is not something that gets used too much for good reason, but you can instruct the virtual environment to also use your system side packages on top of the ones you have in your virtual environment, if you require it. I don't see a good reason for doing it, and it kind of breaks isolation in a way, but the option is there if there's a case for it. All right, so we are now ready to see what creating a virtual environment is, what it means, and what actually does. I apologize a bit for the layout of this slide. I will explain, I will guide you through it. So what you see on the top left is the CPython core. This is the cool thing about Python. It's open source, so you don't have to take my word for it. You can just check the code. And this is what the create function does. It has more lines of code inside of it, but you can think of those as scaffolding. This is the core of the operation of creating a virtual environment. First, you see that it creates the system side packages. Then it creates the configuration, create configuration, as you see below. What it does is create pipem.config, the file that we've seen before. It gets generated in this step by the virtual environment. Next up, set up Python runs. You see the funny exception there, the if block for Windows. That's the part that I'm not going to go into. And then you have a couple of assignments that essentially what it does have the option of copying or symlinking to the operating system's Python install. As you see, the default value or the default operation is to symlink to the executable that it has, the executable information that it has fetched, and then it links to it. So what the creation step does is just generate all of the folder structures that you saw before, sets up the files, and links, creates the symlinks for the Python binary from your file system to the virtual environment. So next up, what is activating a virtual environment? Well, it's actually incredibly simple. It's just changing the path. if you go into your virtual environment and you check the activation scripts, you will see more stuff than this, partly also related to maybe Windows installs, maybe. And what it does is just essentially changing the path. So it takes your shell path, which is where your shell will find the executables for your operating system. And for that session, it says, find me the executables right there in the binary folder. So now you can understand, or now it makes sense, why all of these utilities put their different scripts and different kinds of utilities under the bin folder. So when you activate the virtual environment, this gets prepended to your path, and now you have access to all of those binaries that you've seen before because they are pre-linked or they are found by your shell. And when you run them, it goes to the bin folder and it runs it. It also sets the funny prompt you see when you activate a virtual environment. You see .venv before the shell prompt also being set here. But essentially, it does nothing but change the path in a very broad sense. There's no other magic going on. So there's, I guess, only one question left to answer, which is how it all ties together. We know that we have the binaries foundable by the shell, but how does Python itself, how does the executable, if it is the one, if it's the same binary that is being run by the operating system, and it is, we have seen it, how does it know that the side packages are actually inside of the side packages folder? How does it get bound itself to those contents? And again, we can just check the code for it, and it's not terribly complicated. So first off, when Python starts, it will get the interpreter's path, and it will get the symlink, actually. So it will not, if you want to think about it in a programmatic way, it doesn't get the value of the pointer, it gets the pointer itself. So this will get the path of your virtual environment, linking to the that links to the CPython to the compiled Python binary, and then the side module, which is right here under lib, catches that path. And see, you don't even have to understand code. It tells you right there in the docstring in plain text. So what it does is it checks the configuration in pyvenv.config in order to see if there's the side packages option we've seen before, in order to also grab the operating system's side packages. And if not, it just checks it checks by relative paths. So it says, you know, in the folder where we have the binary, just go one folder up and check the side packages there and use those. So it's some relative pathing going down here, but it's quite simple to understand, and that's how it sort of finds the side packages that it needs to use when the application actually runs. So yep, I hope I didn't speed run through this presentation too much, and this is how the virtual environments work. So now you know.
So thank you, Daniel, for your talk, and we have a lot of room for questions. It's probably okay.
So, what would you prefer, or like suggest us to use, to create your virtual environment? Because there are multiple options, right? You can use Docker,
Yeah, I think it depends on what you're doing with the project and how like integrated you have it with these different package management tools. I think the big advantage that you will have by not using the venv module in Python, so the one that comes bundled with it and the one we've just seen, is that this is by definition bound and symlinked directly to one executable. So there are no two ways around it. Virtual environments, the base virtual environments only have one version attached to them. Other utilities like the old but still active virtualenv and the different package management systems bundle their own ways around it in order to have these more modular approaches where you can have virtual environments for different Python versions. I think it depends, and I think it matters more or less how you are testing your project and how you plan to use it. For example, if you use, for example, talks to do some testing and to review how your code works in different Python versions, that may be taken care of for you. In other cases, if you are very tightly integrated with these tools, there's nothing wrong with using them. Let's say another counter argument you could find for this is that all of these tools which might pull binaries and copy them into the virtual environments are taking up space, but I think that's not a strong argument. The Python binaries are not very large, and it's also, if these tools can be trusted, and they can, it's very safe to do so. You're not incurring any particular risk. If you're very paranoid, you might argue against it, but I don't think it's a strong argument. So I guess it depends on what you do with your project. I think it's totally fine to use any, and it sort of depends on the workflow you have for your concrete project. I think both are fine to use, and use whatever you feel more comfortable with. I slightly lean towards using built-in utilities, but it's not a strong preference, and I think all can be argued in favor of.
Okay, any other questions?
Yes, that's a very good question. The answer is yes. You should use virtual environments inside Docker containers. It's a good practice. Let's say one very common pattern that you will see in well-written Docker files is that you will have a build step where you will drag in all of your dependencies needed for building. This might mean, depending on what you're doing, it might mean just installing the compiler toolchain, GCC or whatever. And in that build step, you compile your packages, and once you have everything ready, you can just move over the virtual environment from the build step to the execution step or to the runtime step using multi-staging, where all the dependencies are already built for you, and that way in your final image you don't have all of that space and all of those dependencies dragged into your container. So yes, it's good practice. It's widely used, and there's good reason for it. On paper, the only caveat I have with this is that virtual environments are actually quite bound to the host machine that you're using, as you see right here. So they are not supposed to be interchangeable. Nothing happens if you're using the same base image, and it's fine to move virtual environments because it will kind of work, or at least the packages that would be pulled will. I would warn against freely moving the vent folder from one place to another. That will probably not work and break in different funny ways because the binary might not be found or things like that. But yes, in the context of Docker builds, it's good practice, and it's recommended. Yeah.
Any more questions? I have maybe. Oh, okay, please.
Would you see better option is like to build wheels than to carry those and like rebuild virtual environment and install them instead of like carrying virtual environment to like host machine or different container?
Well, as far as I understand, wheels are for distribution. So if you pull a wheel, you probably don't need the tool chain to build that. The build step is normally more useful when you actually have to drag in dependencies related to that build. If you are not required to do that, you can maybe just run your pip install or whatever. Yeah, you can install your requirements, and you won't find that you will need to drag additional dependencies. So let's say that it will not be an extra operation that you will have to do, so that you will want to discard the image you're using for building. So so I think, well, the endpoint is sort of the same. It's if you can avoid it, and if you can trim down your build step to do essentially nothing but pip install, it's ideal. If not, then you separate it. But yeah, the idea would be that everything would have already a precompiled. It would have precompiled binaries, and you wouldn't have to add that extra step in between.
I have a short one. So what is the difference between the virtual environment, the package, and the Conda? Is it a big difference, or?
It is, like I'm not an expert in Conda and other Python distributions. Yes, it's quite different, but I wouldn't really be able to go in depth into what exactly makes those two different environments particularly different. But yeah, different Python distributions work differently. It's sort of unfortunate that we kind of have that, but it's become standardized now to a point where we have to contend with it. So yeah, I cannot give too many details on what goes on specifically, but yeah, I would assume that they work in other ways.
I see. So if no one has any question, we can conclude this final talk. Let's thank the presenter again.